I'm actually streaming this time with audio because why not? I might as well explain a little bit what I'm doing because it might be a little confusing if you have no clue what I'm doing. Sound is not muted, so I'm gonna go that. Okay, so yada yada yada. I'll pause that so it's not loading that constantly while I'm running, because that would make my connection speed really slow. Alright. So LuxCS. LuxCS is a DLL library in C# that has a bunch of utilities I'm working on. I have a lot of projects I want to do in the future. But LuxCS is the key because it contains everything that I need to get this thing to work. There's a lot of utility stuff I want to make. I kind of have a problem with feature creep right now where I keep coming with new ideas of things to add, but I mean, it's going pretty well. So delegate extensions. So this whole engine's delegate namespace. Everything in this folder right here. That's what I'm working on right now. I'm making sort of wrappers for delegates, which are different classes that wrap around a delegate, and you can pass in. The whole point of making the wrapper is so you can do things like as the execute, where you can pass in an object array of arguments, and if it returns something, it'll return it. So it's just a silly way of, basically saying it. You can have a list of these wrappers, and then you can execute them, and you can have different types of delegates nested together, and I'll execute them all perfectly. Throw exceptions if the types you pass in don't match, etc. That's what the point of this is. Seems kind of a weird way of doing it, but it actually works really well. Okay, so delegate wrapper. So I'm making some extensions for delegates right now. I'm using reflection stuff. Mutable array is a collection I invented. It's like an array, but you can't change anything in it. It actually is an array. It's just a little different. But yeah, so I'm gonna go. I actually have quite a few collections. These are all collections I invented for different things. Mostly they're clonable versions of normal.NET collections, like dictionary clonable and stuff. But there's also like mutable stuff, the mutable dictionary, mutable array, where you can't change any of the values. And there's a reversible stack, which is an entirely new collection, which I vetted for the command design pattern. It's like you can redo and undo things. It's basically what it's for. It's really two stacks put together and used in a really weird way. But anyways, get return type. So these are extension methods for all delegates. So you can go any delegate dot get return type, and it'll get you the return type of that delegate. And now we want to go public static type array get parameter types this delegate del. This is going to be an interesting one. So I need to go var parameter info equals del dot get parameter types. No. Del method dot get parameters, right? And then I go here and I go var ret equals new type array parameter info dot length. Okay. And I just go for var I equals 0, I is less than parameter info dot length I plus plus. And then I just go ret I equals parameter info I dot, okay, this thing's wrong, parameter info I dot type, no, parameter type. Okay. And I go at the end, I go return. Right. That's all you gotta do. There's all that reflexive nonsense in the background. It just gives you a type array of all the types that the delegate has for parameters. That's all it does. It's a utility thing. You can do all this code to do the same thing, but it does all the code in one function, so you don't have to worry about it. And then I can go public static. No, I'm not gonna. That's all I'm gonna do. Just those two functions. Okay, back to the delegate wrapper. So argument types equals new immutable array type. I need to pass in an actual array that I want to make immutable, and I'm gonna return in del.get parameter types. And there we go. That's literally it. That's it. So okay. So that's the base delegate wrapper. This is the abstract base class. I actually might just make this be normal. This is a public class. Okay. Okay. So I'm actually gonna get rid of all this. I need to have an exception check. Though I need to have argument.length is unequal to argument count. Okay, that's going to be exception check. So public, that's going to be protected. Protected. Void argument count check. Int count. I'm just going to have this little thing. And I'm just going to pass in count. That's it. So this is going to be a little method I can call from this class and its children to quickly check the arguments if they're an exception if they don't match. Okay. So now I'm going to go argument count check arguments dot count. Well, it should be length because it's an array. Okay. Very easy. Not hard at all. And this is going to be just for any delegate. This is just a delegate wrapper for a default delegate. So I'm going to return del.invoke. Okay, so it has any object. Del.invoke. Dynamic invoke, I guess. And then I pass in arguments. I want to pass in an object array. So how do I do this? Dot method dot invoke oh wait, no, I go wait, what did that say? Okay, method base dot invoke. Okay, I go method base dot invoke. I'm gonna go del arguments. Wait. Oh, it needs an object. Okay. So I can't do that. I need to go down dot method okay. I think that's what I need to do. So I do it with reflection. That's not the fastest way to do it, but that's why I'm having all these children classes for different types that'll be a lot faster. They won't use reflection. But this base type will use reflection. Okay. And then func wrapper. I'm gonna get rid of the base. I don't need func wrapper base. So I just go public class func wrapper t delegate wrapper. Okay, the only override I need is execute. I also need to do the constructor public func wrapper go func t del base del. There we go. And I just go here and I go check argument count check, right? I need to go check argument count. I need to name this something different. Check argument count. The verb needs to be first. That's just standard, you know, naming convention, whatever. Check argument count. Check argument count. And then arguments length. I'm just doing that so it's easy to remember, you know, what it is exactly. Check argument count, arguments at length. Okay. And then I need to go have a try block. And a catch invalid cast exception. Okay. I'm going to throw a new delegate wrapper argument cast exception. Okay. And here I'm just going to cast func t, right? I can take del, which is protected, so I can take it from the base class. And I'm going to pass in. Just going to like that. I'm going to return it. That's all I got to do. I actually don't need to have the catch, try catch for this part, because it's going to work no matter what. Okay. So that's my first delegate wrapper. That's one with no arguments. Now, if you look at func, C# implementation of func, it goes all the way up to 15 arguments. So I have to make 15 more of these classes for every single amount of arguments. It might seem kind of silly, but that's the best way to do it for this sort of thing. So that's what I'm doing. It's actually perfectly encapsulated, even though it might seem like it's not. It is, I promise. So you want to do, okay? Okay. And then here I can go T1. It's going to throw an error because it requires an argument now. But now I can just go arguments T1, arguments 0. That should work. Of course, I did this backwards. This should be T. The return type is the last one, not the first one. Okay. But now I need the try catch, because this cast where I have t1, what if this argument 0 is the wrong type? Then it will not cast correctly and throw an exception. So I need to catch that exception and throw the proper exception that I made for the situation. So catch valid cast exception, and I go throw new. Delegate wrapper argument cast exception. Yeah, I'm gonna go to delegate wrapper. I'm just gonna go try. Well, I passed in the wrong argument, so that'll be invalid operation exception. Catch valid operation. Should be operation exception. Operation exception. There we go. And I just go throw new delegate wrapper argument cast exception. Actually, it shouldn't be cast, because it's now handling multiple situations even when it's not casting. And I need more general on how to describe this. So it's gonna be type exception. Argument type. That's all I gotta do. Rename that to type. And this is gonna be type exception. And then I go to func wrapper. Okay. Pretty simple. But the problem is we have to make like a bunch of versions of this for every single func type. And it goes up to 15 arguments, so I have to make 15 of them. Which is pretty monotonous code writing, I have to say. And it might seem very bad as far as encapsulation is concerned, but it's actually really good. It's the best way to do it. Just because this is the way C# is written, there isn't really a generic way to write this. So you have to write it all out by hand, which is kind of silly, but it works. It makes it really fast when you do it. The whole point of this wrapper thing is to make it faster to do certain things. Make it faster to, you know, it's my dog barking, sorry. 1 second. Sorry, so you can have a bunch of these wrappers in like an array or something, or a dictionary, and you can call a certain one, and you can just pass in the argument array as an array of objects, and yeah, that's all you gotta do. And it will handle all the exceptions and everything for you. And it does it all without using reflection, so that's pretty nice, eh? It's pretty fast because of that. I'm actually going to make a delegate wrapper make it even faster. This constructor is public, but I'm going to have a protected constructor. This is going to be an empty one. The empty one is protected, and it's not going to do anything. Why am I doing that? Well, that's so I can go to the func wrapper. Actually, I'm going to delete all the ones except for the first one, because I'm going to change how this works. And this is going to use the empty base, because you can only do that in protected ones. Instead of using reflection to get all the information about the delegate, I'm going to do it using generics. So it's going to be a lot faster, which is the whole point of me doing this. So yeah, I should have done that in the first place. Okay, so I'm going to go return type equals type of t, and then as return equals true. And then argument types equals new argument is new type array 0. Oh, it's an immutable array, so I need to go new immutable array type, and new type array 0. I guess I can import this, so no won't know what I'm talking about, and I can get rid of this thing there. Okay. So now it does it without using reflection at all, which is pretty damn fast. There's no point of doing it like this. It's for speed. You could do it with reflection and it would be a lot cleaner looking, but it would not be as fast. T1. But for certain things is pretty important. Has return immutable array types, and then here I go 1. And I go type of T1. And I go T1. Then I go T1 arguments 0. I got catch the invalid cast, so try. Using try to catch things makes it so it's a lot faster to use try and catch than using if statements. So try catch invalid cast exception. Go throw new delegate wrapper okay, I need to rename that. Argument type. Don't say my name.
My name?
Don't say my name.
My name?
I'm streaming.
My name, my name.
Thank you.
Have a nice day, my name.
Yeah. Close it all the way. Don't. Dad, do me a favor. Dad. When you leave the office, don't close the door like that.
Is there any dirty
Close
clothes
all the.
upstairs?
Close the door all the way. Okay.
Clothes.
I brought mine down. Close it all the way. Don't leave it partway closed because it's annoying. It like closes on its own and startles me. Don't do that. Thank you. I already brought him down. This house is a circus. Okay. And I go comma and I go type of T2. Okay. And I need to go here, and this has to take in T2. And it's going to throw an error because it needs to have the second argument. So T2, argument 1. Good. So it can do all this stuff without reflection. It just does it super fast. But if I want to have just a normal delegate and I'm not specifying what type it is, yeah, it has to use reflection because it has to figure all this stuff out. But otherwise, I don't have to use reflection, which is pretty cool. T3. But T3. This is 3. Already down. No. Okay. Yes?
What towel on your bed make your bed?
Please don't.
Sorry. Huh? Thank you.
I don't know what's going on. Give me a second. Yep. Sorry about that. My house is circus. What can I say? It's something stupid. They were confused about my bed. But it was nothing. Never mind. I live with my parents. Yes, I do. That doesn't really matter. I'm coding. And basically, the story is I'm going to school, I'm learning stuff, and I live with my parents. It's cheaper. There you go. No, I don't live in my parents' basement. They can be picky sometimes, but that's how all parents are, you know. It's not here, T4, arguments, 3. There we go. Okay, so Funk Rapper. Like I said, I have to go all the way up to 15. There's quite a few errors. That's all over the library. I'm gonna fix all the errors. I'm gonna do some tests. Just make sure everything's working the way I expect it to. I'm actually gonna make something to use these for. I'll show you in a minute. I'll make an example to show how these things can be used. I've made these sort of things all the time. I just haven't made a library that has them all put together like this. This is only one of the things in this library. There's a lot of stuff in here. Yeah. Yeah, okay, so that's the T5 one. I gotta copy it all again and add another one. So now I'm gonna add T6. And so I pass in T6. It has 6 types. 6th type is gonna be type of T6. Down here I go T6. And I go T6, arguments 5. Okay. So I'm about 1/3 of the way done with all these, and then I have to do actions and probably predicates as well. Those are all different types of delegates that come with C#.NET Framework. I'm probably going to make wrappers for all of the basic types of delegate. And of course, if I want a custom delegate type, then I have to do it all myself. It's not going to be included in here because, yeah, that's kind of impossible. You have to code it yourself. Okay. And then you go T7. And then I just cast T7. Arguments 6. A lot of casting going on, but it's faster than reflection, so it's okay. Much faster than reflection. And T8. T8. Oh, I need to have a comma here, so it's not going to work. And then I need to have 8 types. The 8th type is going to be type of T8. And this one's going to be T8. T8. Arguments 7. So I need a comma here. Separate the arguments out. And that's the 8 one. So I have to go all the way up to, I think it's 16. Yeah, I think it's 16. So T9. Oh, it's 15. So T9. I believe it's 15. I'll see. 9. The reason I'm doing up to 15 is because that's how many functions are in. That's as large as they get in C#. They can't get any larger than that. If you want it larger, you have to make your own, which is how .NET Framework works. So I'm not going to go any larger than that. If you do want to go larger than that, you actually literally code your own wrapper for it. Don't worry about it, it's all good. Okay. Okay, now I gotta do T10. And then T10. 10. And this is gonna be type of. You might be wondering, so what is a func and a action and a predicate? What is the difference? Well, I'll explain. Really simply, function. The first generic types are the arguments that you can pass into the delegate, and the last type is a return type. An action, all of the generic types are the arguments, and there is no return. It always returns void. Actions always return void. And predicates do something weird. I'll go over that later. Okay, so T10. They return booleans. Yeah. T10 arguments. I might actually not do predicates. I don't know. Probably not actually. Okay, that's T10. Probably just actions and funcs. Yeah. So this is going to be T11. 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 That's literally all I gotta do, but I have to remember to do this part, this part, this part, and this part. 4 things I have to do for every single one of them. If I forget one of those things, it's gonna have a bug. And since there's so many of these, you know, it's easy to mess one of these up and miss it. So I have to be very careful. It would even throw an error, compile error. It'll let me compile still, even though it won't be correct. And see, it's not throwing any errors, but I still have more work to do. So it won't tell me if I mess something up here. I would have to figure out the hard way might never figure it out. I mean, whoever uses funcs with exactly 12 arguments, that's kind of a rare occurrence. So yeah. But I do have to make it for completeness sake. It's just I got to be very careful not to make a mistake. Because the way you're writing this code, it's not like I'm encapsulating it all in one spot. I'm making different ways of doing the same thing 50 times for different types of things. But that's the problem with C# and generic types. You have to do it like this. There's no other way. There's literally no other way. So while it looks ugly and very bad code, it's actually the only way to do it. It's the best way to do it. You can do it with reflection, but this ends up being a lot faster than reflection. Okay. So this is for speed's sake. I'm having this little utility thing. But the good thing is, once this is done, all I have to do is ignore it, and I don't have to mess with it anymore. So it is, in a way, it is encapsulated. It's just a really big chunk of code that's encapsulated. Yeah, it's just a lot of stuff in this to get this to work. A lot of code that is pretty monotonous, so it's kind of silly. But there's no faster way of doing it. Yeah, people have seen me do this sort of thing before with delegates, so they don't understand why I'm doing it this way. But it's actually because in .NET Framework, deep down, the delegates are actually coded like this. There's like different methods and everything for every single type of delegate, with the different arguments and everything. So it's actually a pretty good way of doing it. That's why there's only 15 funcs and only 15 actions. I mean 16 funcs and 16 actions, because they have to hand code every single one, so they can't have an infinite number of them. They have to hand code them all, so they just made 15 and like, that's enough. We don't need any more than that. Because 15, I mean, who really needs a function with more than 15 arguments? That's a lot. That's a good number to stop at. And if you really need your own, you can make it. Yep. This needs to be 15 long. I think this is the last one I'm doing. It's a really long line right here. Man, I have to scroll over. It's so crazy. Okay. Then I go T15. Arguments 14. I don't think I can do any more. I'm going to try. It's going to throw an error if it's too much. So this will work. Where it's going to throw the error will be right here. Will let me do that? It will. Okay. So this is probably the highest one I can do. Wait. No. This is 15. I need 16. Yeah, I already did a 15. I don't think there's a 16th one. Well, let's see. So I'm going to go T16. Oops, 16. And if I try going T16, it will throw an error if I can't do any more. Oh, it's letting me do it. So there's a 16 argument one. Well, I think that's the last one. I don't think it goes much higher than that. I guess this is the last one. For some reason they chose 16 to be their highest number. Probably because it's a multiple of 2. So, you know, programming wise that's pretty important. 16 is a pretty important number. I don't know. Probably something deep down is the reason they did it like that. I don't understand, but I don't need to. Okay, so, but if I try doing a 17th one, I guarantee you it's not going to work. It's going to say func doesn't exist. There is no func with 17. See? It's not working because it doesn't exist. If you look at func, all the overloads, it has all these overloads, but there is nothing above that one. There's only 17 overloads. There's nothing above that one. Because they have to hand write them all and they just stopped at that. Don't ask me why. Yeah, that's it. That's all of the wrappers for func, because I can't make, they don't go any larger than that. Pretty simple. Doesn't use any reflection, it just uses casting, which is faster, and it's pretty fast. Very good. So now I gotta do action wrapper. Of course, this is gonna be object. And it's always gonna return null, because actions never return anything. Okay. I'm gonna go override. The action wrapper is a little different than the func wrapper because it doesn't have a return type. The func wrapper always has a return, which is when the T is always, but the action wrapper doesn't have a return, so it actually has a constructor without any generics at all. Public action wrapper has a version of the class without any generics at all, which is what this is. It's the protected base. And so now I go return type equals type of void. I go heads return equals false. And then I go argument types equals new immutable. Okay, I don't want to do it like that. I go immutable array type. Okay. Okay, I gotta import. Why is that not working? Okay, I have a system for type. Okay. You write type and new type array 0. Okay. And then I have to go check argument count, arguments.count, that length. And then I go del, and then I gotta cast it to be an action. Actually, I don't need to do any casting at all here. I just go del. Well, I guess I can go action. There we go. Turns an action called like that. Boom. That's it. So that's the basic action wrapper for an action with no arguments. And I can go all the way up to 16 arguments as I did with the funcs. So I can do the same thing. And these don't have any return type, so they're a little different. T1, they always have a type of void, and return is always false. Has return is always false. This one's got 1, and a type of T1. So using generics and casting is faster than reflection. That's the whole point of this. It might seem really stupid, but it works. So I'm doing it. T1. And then I go T1, arguments, 0. But the interesting thing is, it's actually going to be very similar to this. Very similar to this. You just copy that, paste it. But instead of func, it's action. It doesn't have a T1. Why does this has T1? Huh? But it doesn't return because it always returns void. And then I just go return. No. Yeah. So instead of void, it returns null, but that's okay. doesn't really matter. You can't go return void. It's gonna throw an exception. So I'm just gonna turn it off. You can kind of guess that's void. It's not returning anything. It's good enough. I'm not too worried about it. Okay. Because you shouldn't expect a return from these anyways. They're actions. So it's just always gonna turn off. So action wrapper, and then I need to do T1. This one has 2 arguments, and now I gotta do the whole thing with 2 arguments. So now I gotta go to the second one. I gotta define what the second one is. Then it has, you cast it to an action T1, T2. And the second one's gonna be T2 arguments 1. That's it. So now I gotta literally do this quite a few more times, like 14 more times. Adding a new argument every time. Silly, like I said, but it's the best way of doing it, so it might, even though it does seem strange. It's very monotonous work. Good thing is, once I'm done with this, I will never have to do it again unless I want to make new types, which I will do eventually, so I will do it again. Yeah, it's a never-ending struggle. Okay. T4 arguments 3. Still cool. Yep, still filming. Okay. And it's picking up everything. Yeah, it is. Okay. It's all good. Gotta copy it every time because I have to add a new one to the last one. So I have to pick up the last one, copy it, paste it, and then add a new layer. 5. Actually, I'm doing something wrong here. I see what I did. I made a mistake. Which is annoying because I had to fix it in every single part I already wrote already. But actually it will take a few seconds. It won't take that long to fix. I need to go back to func wrapper, and if you look at the constructor, I need to add del equals del. That's all I need to do. I need to add that to every single constructor. Because otherwise it's not actually assigning to del and it won't save it. Which would defeat the whole purpose of the wrapper. So it would not work at all. So I have to do this to every constructor all the way down the line. This doesn't look like good code, but it is good code. I don't know how many times I've argued with people about this sort of thing. This is a really weird problem that C# doesn't address. Doesn't have like a fancy little way you can encapsulate it. You have to code it all by hand. Okay. So del. So I just do that to all those, and then I can close the delegate wrapper. Delegate extensions, I can close that. Func wrapper. Okay, action wrapper. And then I go action del. And right here I go action T1 del. Del equals del. Right here I go action T1 T1, T2. Go del. This del. Whoops. Yeah, del. Not deck, del. And this is del. T1, T2, T3. No action. T1, T2, T3. Del. Helical del. And for this one, I go action. T1, T2, T3, T4. Del. The reason I'm making the parameter name be del and not delegate is because lowercase delegate is actually a keyword. So I can't follow. I have to do that because yeah, if I follow the name convention and make it just be a lowercase word delegate, it would not work. And capital delegate is a class name. Yeah, so I just use del instead of delegate to get around all those problems. Of course, the class name part wasn't really a problem, but that's okay. Don't worry about it. So okay, so yeah, That's because delegate is a keyword. Yeah. So getting around that by just saying del instead of delegate. You know what it is. Okay. Six. Yada yada yada. And of course, it has a type of with 6 arguments, so I have to cast it to the proper type, or else it will throw an error every time you try using it, which would be a problem. Mints 5. Okay, then T7. Here, 7. Seven arguments, 7. Oh, it should be 6. I didn't actually. 7. Okay, I didn't do it in the right order. So okay, that all works. Wait. Oh, wait. No, I'm doing the wrong one. Okay. This is T7. Yeah, I went up. I wasn't thinking. I did. See, that's the problem with this sort of code, is that it's easy to make little mistakes like that because you're doing a lot of monotonous typing. Which is why I should generally avoid this sort of situation, but there's nothing I can do to avoid this one. So I should be very careful. And understand that it's going to take a long time to type this. Okay. Yeah, that's good. I got the T7 done. Okay, let's do T8. So I gotta go to T8. 8. So say using reflection, I make my own system. T8, 8. And type of T8. Be much faster than reflection. T8. Okay, after I'm done with these, I'm going to let me think. I'm going to take this I'm going to make a test scenario so I can test these out, make sure that they work. Well, I won't test all of them, but I'll test the basic idea that they work. Make sure there's nothing I forgot about. Sometimes I forget about stuff. I'm going to make a example. Wait. I went to the wrong one again. This should be 8. Okay. Don't screw up. So this is T9. This is the T9 one. Why did that go up? I don't know. Okay. 9. This is type of T9. And then T9. And then I gotta scroll all the way over. Annoying. Okay. T9. A lot of casting. T9. Arguments. 8. Okay. An action wrapper, and then I can just go T10. For some reason it put me all the way. That's weird. Yeah, that's why I was messing this up, because it jumps me down for some reason. It jumped me back up. I don't understand. Okay, that's fine. T10. And this one has 10 types. That's going to be type of T10. And then when it executes, then it casts it to a type. And the 10th argument is going to be cast to a T10. Yikes. Yeah, look at that. It put me all the way up there. Why is it doing that? It's annoying. That's what messed me up all those times before. I didn't realize it did that. Okay, T11. Type of T11. Some sort of Visual Studio bug. This needs to be 11 types. Okay, and then T11. Of course, Visual Studio is not really. This is not something people do that much, so I kind of forgive them for having a bug like that, which is annoying. Okay, so then I can go here and I go T12, and for some reason it jumps me all the way back up again. I don't know why it does that. That's okay. I'm going to go T12. And then I can have 12 types at 121. Wow, that's a big array to manually define. Type of T12. And then it's going to go T12. T12 arguments 11. Okay, then the next one. I just gotta go T13. And it didn't jump that time. That's strange. I don't understand. But that's okay. Okay, type 13. I'm just gonna go type of T13. And it's gonna have a T13 this time. And I'm just gonna go T13 arguments 12. Yep, there's my action wrapper. For 13 arguments, now I'm gonna do 14 arguments. So let's go here, go T14, and it actually did jump up that time for some reason. Why? Why is it doing that? So stupid. T14. And it has 14 types. So it's going to be type of T14. So I can store all the types away without using reflection. Nice. And then I go here, and then just go T14. Then I go here and go T14. Arguments course, it's -1 because it's an array. And that's it. Now I can do 15 and then 16, and then I'm finally done with all these. I can start working on a scenario for testing them out. 15. Which I might have to do some work in other things, which I will show you in a minute. Mainly my interpreter pattern. I have an implementation of an interpreter pattern. Interpreter pattern is a design pattern made for interpreting strings or other things at runtime. And I have like a little thing up here. I can show it to you in a minute. But yeah, my goal in the second is going to be to make an interpreter for reading a command line, and then it will call an action, passing in the arguments you typed in. So it's going to be pretty simple. It will be a command line interpreter, basically. CLI, which is actually in this little namespace right here. I already have most of it coded. I'm just going to have to do some changes to it to get to work with these new things I made. So T15. So then I have to go T15 arguments 14. Okay, that is that. And I have one more I gotta do, which is the 16 one. So I gotta do 16, and there are no more that exist in the .NET framework. 16 is the highest it goes. If I try going higher, it's just gonna throw an error. No, to confirm that by trying to go higher and see if it works or not, which is not going to. But I'll do it just to show you that it won't work. And then T16. So I have actions which, these are the generic types are the arguments you pass in. As a delegate, the generic types of the arguments you pass in. And then I have funcs, which are generic types of the arguments you pass in. And the last one is the return type. So I have wrappers for both of those. I could do predicates, but I'm not even going to worry about that. It's actually fine. I don't need the predicates. They're weird. Okay, so let's just show you that I can't do any bigger than 16. I can then show you, I tried making an action with T17. It's going to be confused. It's like there's no type of action that has 16 generic types. So it's not going to work. 17 generic types, I mean. So it's not going to work, so I can't go that big. So I'm done. I'm not going to go any bigger than a .NET framework allows me to. I could by making my own types of action, defining another file, but that's just overkill. I don't need to do that. Who needs actions with more than 15 arguments anyways? I mean 16 arguments. There's a reason they went that big and they stopped, because you don't need to go any bigger. It's good enough. Okay. That's all that. So now I'm going to I can close all this stuff. I don't need to worry about my delegate engine anymore. I can go into CLI, command line executor. Commands. So these are the commands. It's a read-only dictionary. Meaning you can't write the dictionary with an entirely new one, but you can still access it publicly. Basically what that means. Yeah, so got public command. Oh no, I made it a singleton. I don't want it to be a singleton. This is actually a line executor. It's not a singleton because you can like do it your own way, whatever. Okay, so you can have multiple executors for different command line things and stuff in the same program. So I'm not going to make it a singleton. So command line executor, and it's going to take in an array of delegates. Delegate array commands. That's it. A delegate array of commands. And of course, delegate isn't understood until I include system. I don't need the singleton pattern to be included anymore. Okay. So the singleton pattern, that's just a system I made for making singletons. That's an entirely separate thing. I'm not going to talk about it right now. It's a little complicated. Yeah. So command line executor. So I just passed in the delegate commands. Okay, I actually need to go back down here and I need to make a factory thing. I need to make a factory. So I'm going to make a new class, and this is going to be delegate wrapper factory. This will be a public class. And this is gonna be a singleton. I think I'll make it a singleton. No, I won't make it a singleton. It's just it's gonna be static. Yeah, it's a static class. So it just has a bunch of utility methods on it. And I'm just going to go, this is actually a factory class, so it's using the factory design pattern for building the wrappers. So I'm just going to go public delegate wrapper wrap, and I go delegate del, and it's just going to figure out what type of delegate it is and wrap it with the proper wrapper type. So I need to go, I need a bunch of if statements. If del is func t, wait a second. I gotta figure out what type of delegate this is. So, var return type equals del.get return type. That's one of my extensions I made. That's going to get the return type. And then I go var parameter types equals del.get parameter types. Those are extensions I made that basically do a bunch of reflexive things to get the types of the return and the parameter pretty efficiently. It does all in one method. I can show you right here. There are my extensions, they're in here. So I can get rid of extensions namespace actually. I don't need to have, it needs to just be delegates, not extensions. Okay. But see, get parameter types. It actually uses reflection. It gets the type info array, and then it goes through them and it gets the types, and it just returns an array of the types. And then this return type just goes method that return type. It's very simple what that does. But I just put it together like this, so it's very compact and together, you know. You don't have to worry about it. You just call that method, it gets what you do. You don't have to call that code every single time. And it's extension method, so it's you can call it on the delegate itself. It's pretty cool. Okay, so you just need to include the namespace though. I don't need to include the same namespace that this is. That's kind of silly. I can get rid of all this. So I go if return type equals type of return type equals type of void, right? It's void, then we know we have an action. else if return type else if return type is not equal to type of void. But I'm actually going to comment out all these things because it's not really needed because it's going to return anyways. So why do I need an else if? Because it's going to end in a return, so it won't ever leave that bracket. Yeah. I'm just having that there so you can kind of see the structure of it, but it's not needed because of the returns, how it's going to return things. It's not actually needed to have the else if there. It's just there to help you understand what I'm thinking. In comments. Okay, so type of void. Then I go switch parameter types dot length. Okay, so now I gotta do case 0 return new action wrapper action. Go. Case 1. So I gotta just go down and it's going to have one of these, and it's going to be parameter types 0 dot get type no dot generic type. It needs to be generic type. Get generic. This is a problem. I got to convert this into a generic type from a, type array, type class. I got to figure this out. This is a tricky thing. This is a problem with types. I don't think this is possible, actually. So what I'm trying to do might not be possible. Action wrapper, yeah. How do I do this? Actually, I can get rid of this factory entirely. Let's get rid of this entire thing. I have an idea. Elegant Raptor factory. Get rid of the factory. It's gonna be an extension, and it's just gonna be public static delegate wrapper wrap this delegate del. So I'm gonna make it be a extension method. And think. Man. It's gonna be a lot of reflection. So I'm just gonna go var types equals del.get parameter types, var ret equals type equals del.get return type. Okay. Oh, I know what to do. I gotta use reflection, but it's possible to do this. I know how to do this. So I gotta go probably not the fastest way to do it, but if you want to do it faster, you can do it in other ways. Okay. This is just a single return type. And I go if ret type equals type of void. I go else if ret type is not equal to type of void. This is the same thing I had before. Okay. In the comments, because it's not actually required, it's just to show me the structure of the code. I'll remember what I'm doing here. So I go switch types dot length. Now this is where I'm going to use some crazy reflection. Case 0. Then I just return new action wrapper action del. Okay, now I go case 1. This is where it gets really strange. 1. Okay, I'm going to return new action wrapper okay, I'm gonna have to var wrapper type equals var wrapper type equals, I'm gonna have to use you do it all reflectively. So my wrapper type is going to be action wrapper, and then T1 is going to be no, I can't do it like that. Wrapper type equals Reflection. Oh, come on. I gotta figure out what the type is, and then I go activator. I need to use activator dot create instance. This is more like pseudocode at the moment. Create instance, and then I need to go. Yeah, there we go. So this is the one I need to do type, and then the args. So it's going to be create instance of wrapper type, and the args are going to be del. But I'm going to cast it to be that's del. So I need to use activator to do this. Wait, what? I was overwriting it though. Yeah, that's a bug. I got IntelliSense is messing up a little bit. I gotta clean. Okay, so I cleaned it. So if I look at the error list, it should be fixed now. Yeah. Well, that was from the last time I compiled. I see what that is. Okay, don't worry about it. So and I return whatever the heck this is. Wrapper type is going to be a type. Type wrapper type equals. How do I get? Okay, I want to get the action wrapper with get type of name and generic arguments reflective generic types reflection C#. No. Okay. Make generic type. Wait, what is this on? Type wrapper type equals type of an action wrapper. And wrapper type dot I think it's this. Make generic type. Okay, so I need to go type of wrapper, action wrapper that make generic type, and then I need to go types. Okay, that works actually. Okay, create instance. Um, CV type. Oh. Oh. Ta-da! That's all you gotta do. And var actually I think a switch statement is not the best way to do this, but I'll fix it in a second. So this is var action type equals type of action make generic types. Okay. Yeah. So I go if types length is equal to 0, and I just do this. I go else if types length less than or equal to 16, and I just go right here. I go else return new delegate wrapper del. And I don't need an else. I could just go else I actually don't need these. I get rid of these too. Okay. You can kind of guess where the brackets go because, yeah, there's nothing else after it. I can go if types dot length equals 0. Types. Whoa. If types. Why is that not? Oh. There we go. It had too many closing brackets. I messed up. Types at length is equal to 0. And just gonna go return new. I'm gonna go var. No, stop Cortana. Okay, stupid. Var wrapper type equals type of, and then I just go func wrapper make generic type, and then I just go I can just pass in, you know, ret type. Var function type equals type of func make generic type, and then I go ret type, and then I go return delegate wrapper. I go activator create instance wrapper type oh wait, no, I actually don't need action type. I don't need function type. Wrapper type. Oh, I'll figure it all out on its own. Yep. Let's go else return new delegate wrapper, and then I just go delegate wrapper and then del. Okay. No, else if types dot length is less than or equal to 16. Let's go var wrapper type equals type of func wrapper make generic type, and then I just go yeah, I go types ret type, problem is it needs an array of types, and that's so I have to combine it together. So var generic equals types dot toList. This isn't a link. Types dot toList dot add ret type Okay, I can't do this. I'm online. Generics list equals types dot toList, and then I go generics list dot add ret serum type. No. Add ret type, and then I go here, go generics list dot to array. Yep. And finally I go return delegate wrapper. I go activator dot create instance wrapper type generics and del. That's weird reflection nonsense, but that should work. Okay. That's all good, man. Okay, it's all done. So I'm done with all this junk. All that junk is done. Classes. So let's go to the command line. So I need to go to command line interpreter. This is all fine. This is an interpreter for command line. Now else if bool.try parse raw out bool b val turn b val So this is an interpreter. So you pass in a string, it interprets it, and then it returns the answer. That's pretty much it. So command line arguments. So you can pass in command line arguments and it'll interpret that they mean. You know, if you pass it in int, it'll It turns it into an array of objects, basically, is what it returns. An array of objects. Strings and ints and longs and floats and bools based on what you typed in. And it takes into account quote marks. So if you have stuff surrounded by quote marks, it'll take it as a single string argument. Or whatever, you know what I mean. I can get rid of the parse argument for this because it has to be a string. It's surrounded by quotes. Okay. Okay. That's pretty good. Inline executor. Okay, let's try to rebuild the solution and see what it does. So there's a few things that are weird. Yeah, I need to get rid of this extensions. Interpret string. What is this overriding? This is a BRAC parser. Oh, this is BRAC parser. So this is not anything I'm not using right now. This has to do with the interpreted programming language I was using. I was using interpreter pattern for this, but I changed the pattern, so this is not going to work anymore. So I'm just going to go advanced comment selection. Actually, no, I can fix it. I'll fix it so it works. It won't be that hard. So this is not an array interpreter. I need to go to design and then behavioral interpreter pattern. And this needs to be a string array interpreter. String array interpreter. String array interpreter takes, okay, T1 and T2. So it returns a T, and T2 is the data manager. Okay. So I need to go back to BRAC parser. This needs to be BRAC interpreter. First thing has to be BRAC interpreter, not BRAC parser. BRAC is a big thing. I just want to get working for now. Actually, no, it needs to be a BRAC parser. Because, yeah, that's how I have this organized. Okay. So it's going to return an object array. And it needs to have a BRAC parser data. Okay. It's missing the interpret string method. Okay, undo. Okay, interpret string. This just needs to be interpret. Interpret. Okay. Interpret loop. Yeah, this is interesting. It has a path in there and all that stuff. Okay, let's get rid of... I need to make the interpret loop. Let's go into interpreter pattern. Interpret loop is just a really quick yeah, so I need to go region protected utility methods and region, and then I need interpret loop. So sorry, this is confusing, don't worry about it. Public, no, this is protected. String array interpreter. So protected T array interpret loop, and it's going to take in string raw, and then T2 data, and all it does is it goes for var I equals 0. Get this right. I is less than raw.length I plus plus. And then I just go, I can make it overrideable too. Make it virtual so you can override it if you need to. I plus plus, and then I'm just gonna go, you know, interpret char raw I data. Okay, and then I'm gonna go var result equals new list t. I can go result. Let's go ref and ref. And then at the end I go return result dot to array. I don't need the ref keyword for that. Okay. That's pretty simple. It's a, so I can put the loop in some section method and encapsulate it for interpretation. It has to do with the interpreter pattern. It's a little confusing. If you don't know how this works, don't worry about it. But I'm encapsulating each character being interpreted into its own methods for each character, so that it kind of I have it all encapsulated very nicely. There's a reason for doing it this way. It's hard to explain though, but it works pretty good. So interpret char, and this is not a reference anymore. There we go. So that should be all the errors in here fixed. Yep, it's all done. Repaired. So I can build this, try to rebuild it again, and it has different errors. Okay, command line interpreter char. So I gotta work in fixing this. This is not by ref anymore. I think that's the only problem. I think it fixed that problem. Okay, so string converter doesn't exist, so I need to go toString array interpreter. So toString array interpreter. Yeah, this is all completely bad. Well, actually this code in here is correct. I just have to make it proper. So, toString array interpreter. I don't need to reference that. Object, and then no. This whole thing is stupid. toString array interpreter. Let's get rid of all that. So, interpreters are from string, not toString. BRAC converter needs to be gotten rid of. Object BRAC extension BRAC extensions. So I'm gonna get rid of BRAC converter. Okay, let's close all but this. Okay, this will be public static class BRAC extensions. Conversion extensions. And take BRAC. Okay, so I can now go public static string to BRAC string this object array statements. To BRAC string. Yep. Wait, no, I'm not gonna do it like that. Yeah, let's just get rid of this. Public static string to BRAC. So BRAC is a programming language. I'm not going to explain it right now. I just need to get this finished so I can get the program working without bugs, so I can actually compile it. Array statement. That's one statement. Yeah. So let's go string builder var token var ret equals new string builder. The string builder is the fastest way to build a string. You know, put stuff together to make a big string is string builder. Concatenation. If you're doing a lot of concatenation, use the string builder class. Makes it faster. There's funky casting here. This should work. Okay, now it's gonna call this method. Then I'm just gonna go ret.add to be append. This is how you concatenate with the string builder. Just go append, add it to the end. Actually, I can do this in the constructor. Okay. And then I just go for var I equals 0, I is less than statement dot length I plus plus. And then I just go and then I go ret.append statement I.toString. Well, if I is less than statement.length minus 1, then I go ret.append space. And I go ret.append so I go if statement I is object array, then I'm going to go ret.append object array statement I to brack string and go else. I do this stuff. Pretty simple. Let's return ret.toString. Thank you. I go ret.add append object array statements I to brack string. Ta-da! And then I can also add a new line, ret.append new line, just to help keep it cleaner. dokie. Okay. No, it's not gonna add new lines for this one. Okay. So that's the new conversion engine. It's completely different. So building this should work fine. Rebuild solution. Nope. Equals new dictionary. Yeah. Right. Another thing. Data clone. Yeah, should be that. Oh, it's a dictionary. Okay, that should fix all the problems. Okay, rebuild. Sorry, this is all a bunch of confusing stuff, but I just fixed all the errors in my entire thing, so it actually compiles perfectly. Okay, that's pretty cool. But now, the next step is going to be make sure the CLI does exactly what I want. Why not interpreter? This interpreter is pretty good. I don't need to edit this anymore. I made it good already. So I use the interpreter pattern. It goes through every single character. And it figures out what's going on. And it's kind of a state machine. It has this command line interpreter data, which is a class, which it uses to store information about the current state of the interpreter. Like, is it currently in a string? And what is the token it has right now? You have to make your own data class whenever you're making an interpreter. You just define it and it passes it around. It has all the stuff it needs on it. It's the fastest way of doing it. Okay. Not bad. But now my command line executor. So this has a dictionary of delegate wrapper commands. Clonable dictionary. I'll make it be a clonable dictionary. Which is a thing I made. So making a clonable dictionary, which is a dictionary but you can clone it. It just has iClonable added to it. So it's kind of useful. So I'm using that instead just because. So you can clone the dictionary and, you know, make a copy of it. If you so feel like. command line executor. So can I make this be action? Yeah. So they have to be actions. No, it has to be delegate. All delegates. Okay. Action wrapper. I'm actually going to add a public class abstract class action wrapper base delegate wrapper. Why am I doing this? Well, so I can have a hook that all the action wrappers are that share, so I can specify, you know, this is an action wrapper really easily. So I can go public action wrapper base. Of course, this is protected. So base, and it goes base. I can actually put common things that they all share in here. Delegate del. And I can just cut this and paste it here. And then I just go del. I go action wrapper base. Okay. So I do slight changes to all this. I'm going to make it so it has a base class that they all share, so I don't have to... It encapsulates some of the code together, which is pretty nice. Also, it makes it so I don't have to... It also groups them all together with a superclass that they all share that the funcs don't have. So I can use that to distinct these from the funcs really easily. This is all a bunch of weird code. It's confusing as heck, but it'll make sense when it's done. I just have to slowly put it all together. I talked about this before, this section of code, and how it's kind of monotonous. It doesn't look very well encapsulated, but it actually is. It's because it's because of what I'm doing is so weird that you have to type it out like this. So believe me, it's actually very well encapsulated. This is a strange thing I'm doing. I'm genericifying a generics, which you can't really do. So I have to make a bunch of types for every single type of generic that you get. Which is actually what they do in the .NET Framework too, deep down. When they have stuff like this, you can actually see code that looks like this in the .NET Framework for certain situations. So it's not like this is a stupid thing that no one ever does. It just, you don't see it that much because it's not something else they have to do. Okay, and then I'm gonna go here and I'm gonna make a func wrapper base, public abstract class func. wrapper base T delegate wrapper, and this is going to go public func wrapper base, and it's going to have a delegate del base. Actually, I don't need, yeah. So I just cut this, paste. There we go. Func wrapper base. So I copied that, and I paste it here. Base del. This needs to be protected. Only children can access this. Okay. Yipberry. Yippity day. Okay, and delete. And pass that in the constructor. Okay, next one. Paste and delete. Pass it into the constructor. Next one. And delete. Pass that into the constructor. Slow filming, right? Yep, it's slow filming. So I had a bug where OBS would crash randomly. It had to do with it being out of date, and I had to update it, and I fixed it. It was so outdated that it just would crash for no reason, which was really annoying. But I don't have that problem anymore after I updated it. I was just making sure, though. You know, sometimes things mess up. Because computers can be funny sometimes. They're sometimes really annoying. You know, sometimes it's always the fault of a person, though. It's never the computer's fault it messes up. If OBS was crashing, it was the fault of the people who made OBS. It's not the computer's fault. The computer's just doing what it's told. It's doing what it's supposed to do. Very rarely is a computer at fault for something. If ever. If your computer is at fault for something, it's usually because you need to update something, or, yeah, then again, then it goes back to being your fault. Welcome to the life of a programmer. Everything is your fault, and you have to deal with it. You have to live with the fact that everything is your fault. Okay. That's pretty good. So these are going to be action wrappers. Action wrapper base. This is going to be action wrapper base array commands. String command names and then commands, and then I have to go if command names equal to null, throw new null argument null exception. God, what the hell? Command names. If, I just gotta do this really quick. If commands equals null, throw new arguments, no exception commands. Neither of those can be null. Okay. And then Actually, I can go if del equals null, throw new argument, null exception, del. Yeah. So I can do it like that, and then I can go to func wrapper, very top, and then just kind of go like that. Okay. Yada yada yada. So then I go for var I equals 0. I is less than command names dot length I plus plus, and then I go commands command names I equals commands I. And I have to go also if command names dot length is not equal to commands dot length, throw new argument exception, argument exception, command CLI. Let's add an exception here. Executor, constructor, array, count, mismatch, exception. Let's go with exception. Okay, public int expected count get private set to be protected. Public int found count get name count command count get protected set. I go public executor exception, and then int name count, int command count base, and then I just go CLI executor given plus name count to string plus names and plus command count to string commands when matching counts are required. Okay. And then I just go down here, boom, and I go name count equals name count, command count equals command count. Okay, custom exception, there we go. It's a very weird exception. I'm just gonna throw new, and this is the only place I'm ever gonna call it. And that's gonna be command names length and length. Okay. Kind of seem weird, but it's good enough. Okay, that works. Copy paste, and in this copied version I can rename it to be command not found exception. And then I'm going to have already declared exception. Okay. Command not found exception. String. This would be command name. Command name. String command name. And commands of name. Command of name plus command name plus was not found in executor. Okay. And then I just go command name equals command name. Command name equals command name. I'm gonna go invalid operation exception. And this one is going to be argument exception. Okay. The reason that's bugging out is because I have a second definition of the same class right now. This one. This is going to be operation. Valid operation exception. And this one is command already declared exception. Actually, no, I don't need to do that. I don't need command already declared exception. That's fine. So if I just go to command line executor, public virtual void execute command. This is actually just a public class. Doesn't need to be abstract at all. And I can just go. Yep. So I go. Commands name dot execute arguments. So all the hard work I did before allows me to do that in one line. Nice. Okay. Inline executor. Yeah, so that's really silly. All this hard work it did. Okay. So now I can make a new project. Add new project. And this is going to be a console application. .NET Framework console application. This is going to be test app. So it's going to be a testing app. So I just made a simple console app. Just for testing things. So I can now Don't worry about the namespaces, it doesn't matter. So I'm going to add reference to LogCS. Okay. Then I need to go into my solution and should be multiple set startup projects. And I go multiple, and then I go here and I go start. Say okay. So it builds a library and it builds a testing app and then it starts the testing app. That's what it's going to do. So now I can just go command line executor, var executor equals new command line executor. And expects an array of action wrapper base. So action wrapper base array. Okay. Wait, action wrapper base. So I need to go to action wrapper. Make sure I did this right. Yeah, action wrapper base. New action wrapper base array. Okay. I'm going to just pass in my actions. So I can go new action wrapper. And I just go here, console.write line print. This test worked. Okay, this test worked. And then I also need my first argument is going to be a new string array. The first one is going to be test. I need to come here. Okay. It's kind of a weird constructor, but I put it multiple lines. Yeah, you could do this all in one line. I just kind of did that so you can read it easier. All right. So, that's good. Okay, so that's my executor. And then I can go do while, okay. So do while loop, while on. Okay, so I can go var, this is going to be my var cont equals true. So while cont. This is kind of a stupid one. I could put var cont up there, and then stop can actually I can go down here and I can go new action wrapper. I'm gonna make this easier to write. This is just for, and then I just go cons equals false. Do it in the delegate like that. There's another command. Con equals false. Do while cont. Okay. And then I'm just gonna go var line equals console dot read line. Then I'm just gonna go, you know, object array var final equals final equals commands as singletons dot get instance command line interpreter dot, it's a singleton class and it uses my singletons management system. So I go singletons dot get instance and I'll get my singleton instance of this, and it's getting interpret console.read line. Okay. And then I just go executor dot execute command final 0.toString. The arms are going to be final dot skip 1.toArray. Okay. Let's see if this works. So the first command I'm going to try, oh, it's okay, so it threw an exception. Get instance. Type not singleton exception. Yeah, so I got to work on my singletons. There's a bug with that. I never actually tested this yet, so it's a good thing I'm testing it. Okay. Exception. Okay, I thought I had like a... Okay, I gotta fix this. Type not singleton exception. Okay. I gotta actually add a public string type get protected set. And I just go type. Let's go type this type. Okay, just like that. So now when I run it, I can see in the exception the type. You can see a type that's messing up. See type, and it's okay. Base type is going to be okay. The subclass of singleton. Subclass of singleton. So command line interpreter is a type of string array interpreter, and string array interpreter is a type of interpreter. Interpreter is a type of singleton. So it is a singleton, it just goes all the way up. Oh man, but something tells me it's not going to work that way. How to determine if class is subclass of type. This is confusing. Okay. Hmm. Okay, let's do this. Bar class. Oh, whoa. Bar obj equals. Okay. There you go. If obj is singleton. Oh wait, no. This is fine. I just need... I see what the problem is. I need to have a not sign here. Okay. That should fix it. So I say test. Okay, stop. Yay, it works. Okay, so that's exactly what I wanted to test. So it works fine. I can make commands as with delegates, and then I'll execute those delegate commands perfectly. Say I made the commands down here, the names of commands up here. I type in test, and it does that. I type in stop, it does that. Of course, I need to make it so I don't have to pass it a bunch of arrays and stuff. But this is a good start. Very good start. Okay, so I need to go to command line executor, and I need to go try, and I go catch, command not found exception. No, catch, key not. Key. Okay, wait, what's the exception called? I gotta do this really quick. Key not found exception. Yeah, so I gotta include the right thing. Okay, so try. Catch. Key not found exception. Throw new command not found exception name. Okay. And of course I can go public virtual void execute command object array command, go execute command, and then I go command 0.toString command skip 1.to array. Some link to do that. So now I can go back to my program and I can actually just type in final. I can actually take this whole thing cool. Get rid of that. Get rid of this line. I don't need final anymore. Okay. Cool. Test, and it says command of name test was not found in executor. Okay. I'm going to go to command not found exception. And add some escaped quote marks around the command name. So now I'm going to do it. Okay. And then I just go test. Test start. Cool. So let's try doing an argumental command. So I'm gonna make a silly one. This is a very silly command. Okay, let's close all. I'm gonna go into command line executor. Now I need to go to program, all the way down here, into program. That's what I need to do. I'm going to make a new one, which is going to be add. And this new command is going to be new action wrapper int is going to go a b. Okay, and they're going to go console.write line a plus b. That's it. Add a 2, 3. Okay. Valid cast exception. So add action wrapper type int. Add 3. So what's it passing in? They're floats. Oh. So I'm gonna go back to my command line interpreter because I see a problem. So it should do ints first. And then longs, then floats, then bools, and then finally just makes it be a string. Okay. Add 3, 6. Add 100. There we go. See? So I made a command for adding two numbers together, and it prints it out to the console. So it's just a simple method of making a command line system. Now what if I wanted to have a parameter number of things, or parentheses or whatever. That's not what this is for. I got another one. Print. And I can go action wrapper string. It takes like one string, and it's gonna be a console.write line a. So I can go print test and print test. Print this is a test with quotes. This test with quotes. See, so it detects the quote marks and it makes that be a single string. Stop. Okay. Isn't that cool? So I can make command line stuff. I'm going to make it a little better than that. So all the functionality, all the calculations and everything is done for you. This is all you would have to do in your program to make it work, is this stuff. But I'm going to have to make this executor creation process be a little simpler because it's stupid. Yeah, it's very stupid. How you're passing in two arrays, that's annoying. So I'm going to go here, CLI. I'm going to create a new item, and this is going to be command line action. Public class, command line action. I'm just going to have a public string name, public delegate action, right? Okay. Now, action wrapper base action. And public command line action and string name. Then action wrapper base action, and then I just go, name equals name, action equals action. It's really simple. Okay. Then I go into my executor and I change the constructor, so instead of that it needs a command line action array commands. Then I go here and I get rid of this weird thing. I don't need that anymore. Get rid of that namespace right there, the CLI. Okay. Then I go for var I equals 0, I is less than commands length, I plus plus. Then I go commands I dot name equals commands I dot action. Easy as that. And so now I can go back to my program and I can change how this is made. So now I just need to go new command line action array. Okay, okay. New command line action array. So instead of two arrays, it's just one array. And I go new command line action. And I go I go test And they go new action wrapper. Console.write line test. Okay. Yay. Works. I could try the wrap command. I go dot wrap. Yeah, okay. Actually, I'm not doing that. Okay, that's fine. Good, good, good. And I can do some other funky things. And I can go dot to lower. So it's case dependent. Execute command. Yeah, okay. No, it's case dependent, the way it works right now. So test, and it goes test. Types something it doesn't know, it throws command not found exception. Okay? Which you can catch and do whatever the heck you want with it in your own program. Okay? I want to make some special things. I'm going to new folder. This is going to be delegates. I'm going to make some special delegates that are not included in the .NET framework. This is going to be custom delegates. This will be for special situations. It's not going to be a class. It's just going to be public delegate void, and then it's going to be, you know, action param delegate param action t and param t array args public delegate void param func t1 t params t1 array args. So those are new delegates that are not included in .NET, but they're basically the same thing. There's like a special type of action in func that takes in a parameter amount of arguments, so it can be any number of a certain type. So I can now go to action wrapper, add a new wrapper for this special custom delegate type. So I can copy and paste this down here. This is a param action wrapper. And it's just going to be T1. Param action wrapper. And it's going to take in a param action. And then yeah, I'll do it like that. This is array action. It'll be param, be array func. Okay. Array action T1. Equals new. Okay. I go type of T1. Let's go. Array action. Okay. I just need to go for t var final equals new t array arguments dot. Let me check that. Length. All right. This is array action wrapper. For var I equals 0, I is less than arguments, length, I plus plus. And then I just go final I equals T1 arguments I. Okay. Okay, then I go to func and I go all the way down. It's the array func wrapper. Array func T1 and T. Argument types equals new mutable array type, and then 1 is just T1. And then execute. So this turns into array func. Okay, I can go down to the action wrapper one, and I have all this. Let's copy that, and then let's grab this whole thing, paste. Okay. Okay, so this is array func t. First I return t. I don't need to do that because it automatically does it. Okay, cool. So why would I have the array funcs in the array action? Well, now I can go to here and go add a second one to here. I can go new command line action, add new array action wrapper, and then it's going to be int. Okay. All right, and then I go var I equals var ret equals 0. Okay, I can this is actually going to be a legit function in here, so I'm gonna var ret equals 0. I go for var I equals 0. I is less than a.length I plus plus, and ret plus equals ai, and then I go console.write line ret. Okay, so by doing it like that, I now can pass in a variable amount of ints and add them together. So if I go here and I go add, something's not right. Oh. Yeah, I see what I did wrong. This needs to be final. And func wrapper, I need to get rid of this, and this needs to be final as well. Okay. Add. Add 3, 3, and 3, 9. See? Add. Add them all together. Look at that. Isn't that cool? Adds all those numbers together. Now I'm going to go back to here. I'm going to just make it be float. So it just does floats, because what if I pass in weird types and stuff, you know? So yeah, that's all it does. So it has to be actually float. Okay, so let's go here. F. You added F there. Okay. Add. Add. Look at that, isn't that cool? Adds them together. And this is going to be public virtual. So you can override it with your own way of doing it if you want. Cool. Pretty nice, huh? You can make your own command line actions, whatever. Those are pretty good. Nice. Alright, I don't need to do any more testing for now. It's pretty good. In fact, I'm gonna upload this to my repo. My public repository, I'll update it. Okay. LuxCS, I need to go to my repositories, public, LuxCS. Okay, so I'm gonna go here and delete all of these folders. Delete. And I go in here, deleting the old versions of it. Then I'm gonna add the new versions of everything. Math, engine design, and collections. Okay. Very nice. So I got a very basic stuff done. This is not versions. Let's describe the changes I've done. Okay, so I've done quite a few things. Refactored interpreter pattern. Finished CLI. Refactored CLI. Brack. I'm gonna do a bit of push. So let's see. It's pushing now. It's up there. Let's see. LuxCS. Actually, I'm just gonna... Alright, I'm done filming for now. Thank you for watching, guys.